Hi everyone. So in this video, we are going to talk about what is physics, and along the way, I will also provide some examples, and I hope that will help us appreciate the beauty of physics. All right, so what is physics? It is study of events that can be described in terms of these seven basic independent quantities, and these are called physical quantities. And they are listed here: length, mass, time, current, temperature, amount of substance, luminous intensity. So there are, as you can see, there are seven of those. Now let's talk about basic. So sometimes you'll notice the word basic or base or fundamental, they all mean the same thing. Now what does it mean? Here I have the line drawing of a person. So what are the basic elements that make that drawing? So we see some circles and some lines. So this whole drawing can be made with circles and lines. So circles and lines are the basic elements that make that drawing. Similarly, if you look at an atom, the basic elements of an atom are neutrons, protons, and electrons. Similarly, so these are the basic quantities which help us study physics. So that's basically the meaning of basic. And then independent, what does it mean by independent? That means if you take any of this quantity, it cannot be derived based on other quantities. So that is independent. So the opposite of that is derived or dependent. For example, let me take speed. Speed is a dependent quantity or derived quantity. I can derive it from length and time, like so. Length over time. So length and time are independent quantities, and then I can derive speed based on those two. So that is a derived quantity. All right. So there is another thing that you will hear: change of base. What does it mean? Now, so these seven quantities, scientists have agreed to take these seven quantities as the base quantities, but sometimes in some situations we may decide, that length, I don't want to take length and time. Instead, I want to take speed and time as the base quantities. So if you look at this expression, there are three variables: speed, length, and time. And if I know any two of those, the third can be calculated. So in that case, if I want length to be dependent, I can write it as length is equal to speed times time. Now here I'm taking speed and time as the independent quantities, and if I know that, I can calculate length. So I change the base. So instead of length and time, I have speed and time as the base quantities. We'll talk more about this in the next chapter, units and measurements. All right, so the next is, along with this list, sometimes you will see something called plane angle or simple angle and solid angle. So these are supplementary quantities. They supplement the list. In some sense, they enhance this list. They are not base quantities. They are not fundamental quantities. They are not independent quantities. In fact, they depend on length. But we will not get into the detail here because we are going to study about it in the next chapter. Now, what is physical versus non-physical? So anything that comes under this or derived from this, we call it as physical quantities. And some examples of not physical quantities are, for example, love or hate, or happiness and or sadness, intelligence. So they cannot be derived from these quantities. So those are some examples of not physical quantities. All right. So I wanted to give you a brief roadmap where we will see these quantities. Actually, length, mass, and time, we will start seeing that in motion from the first chapter, but actually we'll see that throughout the physics, right? Current comes in electromagnetics, temperature and amount of substance, that will come in thermodynamics, atomic physics, luminous intensity, it will come in electromagnetics and optics. So I'll briefly talk about each of these quantities. Actually, it is good to know these seven quantities, but actually there is no need to remember it at this point, because we are going to see this so many times that it will automatically you will remember. So but it's good to know. All right, so length, mass, and time, these three are probably the most used in our daily life, right? For example, here is Usain Bolt. He is the fastest man on earth. His length or height is 195 centimeters. So I'm talking about length there. He weighs 94 kg, and there I'm talking about mass. And his world record is 100-meter. Again, I'm talking about length. Is in 9.58 seconds. There I'm talking about time. So next, current, we will we'll see when a light bulb glows or when a fan runs, there is flow of current. So uh, so okay, next is temperature. Like when you have fever, we measure the body temperature, or when it is too hot, the temperature is high. In winter, the temperature is too cold. We are talking about that temperature here. Okay, amount of substance. I will spend a little bit of time here. So it's simply a count, right? For example, like a dozen. Dozen means 12. Another example is mole. Mole is 6.022 times 10 to the power 23. This is called Avogadro's number. This is a very special number. Why this is a special number, we will see it in the next slide. But many times actually students are confused between amount of substance and mass, because they sound similar, but they are independent. All right, so here is an example. Here, I have one watermelon and some potatoes. They have the same mass. Let's say this is 3 kg, this is also 3 kg, but they have different count. Here I have only one watermelon, here I have maybe 25 to 30 potatoes, right? So they have the same mass, different count. Here is an example. I have the same count, one watermelon, one potato, but they have different mass. So as you can see, they are independent. I'll give you another example. Let's say you are having a dinner party. You want to invite some guests. So when you call them up, they say, okay, how many adults, how many kids? So you want to get a head count so that you can prepare dinner for them, right? You don't call them and ask, okay, what is your weight, right? How heavy you are. You call how many of you are coming, right? But if you want to buy sabji or potatoes for the to make dinner, you don't go to the shopkeeper and say, give me 10 potatoes, because potato can be this small or this big, right? So there you give me 10 kg potatoes or 20 kg potatoes. So there we use mass. So this is a simple example, where we use count, where mass is more appropriate. All right. So regarding the mole, right? The mole is a special number because 1 mole of protons or neutrons, they weigh the same. Like 1 mole of that weighs 1 gram. That's why this number is a very special number. Like for example, if I take 1 mole of hydrogen, which has 1 proton, the electron mass is actually very negligible compared to the mass of the proton or neutron. But mole of this will weigh 1 gram, whereas 1 mole of oxygen atom has 8 protons and 8 neutrons, so it will weigh 16 grams. Now, if I take 16 grams of hydrogen and 16 grams of oxygen and mix it up, we know that hydrogen and oxygen combine to give water. So each oxygen is attached to two hydrogen molecules, right? So if I add 16 gram of hydrogen and 60 gram of oxygen, I'm not going to get 32 grams of water. Instead, 16 gram here is 1 mole. So 1 mole is going to combine with 2 mole of hydrogen, because 1 oxygen combines with 2 hydrogens, and that will give me 18 gram of water, and remaining 14 moles of hydrogen will remain, right? So you can see, here the number of atoms are important. The count is important, not just the weight, right? All right, we'll see this a lot in chemistry and also in atomic physics. So for now, this should suffice. All right. Okay, luminous intensity. Think of it as brightness of light. We will talk about it in more detail later. For now, that should be good enough. All right. So physics is study of events using those 7 quantities, physical quantities, right? So I have 3 simple examples here. Let's see which can come under physics and which will not come under physics. Falling of an apple. So if I have an apple, I don't have an apple, but I have a ball. So if I leave it, it falls. Now, how it is going to fall, I can completely describe using actually length, mass, and time. I don't need anything else. So this will come under physics. How about frog jumping? If the question is why can a frog jump, why cannot an ant jump, that actually depends on anatomy of the frog, and that comes under biology. But let's say the question is, let's say the frog can jump at a maximum speed of v and at an angle theta, then how far can the frog jump? That can be completely described using length and time, so that will come under physics. How about setting tomato price? So during the season, tomato price is maybe 10 rupees a kilo, but during the off season the tomato can cost 20, 30, even 50 rupees a kilo. In small towns or in small villages where the tomatoes are grown, the tomato may cost 5 rupees a kilo, but in big cities where tomatoes get transported to that city, the tomato may cost 50 rupees a kilo, right? So the setting the price of tomato, we cannot do it with those 7 physical quantities. That actually depends on demand and supply, so that will come under economics. All right, so these are 3 simple examples. Now, what is a typical process when we study an event? What is the typical process? Usually, we observe the nature, we observe an event, and then we try to formulate the laws that govern that event using those 7 physical quantities that we saw earlier, and we use math as the language. Basically, we make formulas, right? Okay. And then we try to explain other natural phenomena, or we try to exploit that to make our own things, explain and exploit. So I have so remember that nature does not work on a whim. It follows certain laws, and one big part of physics is able to figure out or discover those laws, right? So this is often a cycle, right? All right, so here is, I have 3 examples. Here is the first of that. This is probably the most famous example of physics. Sir Isaac Newton was sitting under an apple tree. The apple fell on his head, and he wondered why the apple fell down, why not it went up. And from that, he discovered the law of gravitation, and he has a set of other 3 laws called Newton's laws of motion. So you know, using this, we can explain why the Earth goes around the sun or why the moon is going around the Earth. And we can also exploit this or make use of this to send our own satellites around Earth or send our own satellites to Mars. Like that's how for example, the Mongolian, that's how the Mongolian was sent, right? So as you can see, a simple observation can lead to very consequential result, right? So that's the beauty of physics. This is the second example. When you drop a stone in water, you can oftentimes you will see ripples. I mean, all the times you will see ripples. Uh, so that is described by something called the wave equation, and we can using that wave equation, I can explain like when somebody is talking, how I can hear. So that can be explained using the wave equation. The sound travels in air as a wave, pressure wave, and we hear that comes to our eardrum, and that's how we hear. So that can be explained using wave equation. We can also make use of this properties of the wave to design stethoscope. Stethoscope, probably you all know about stethoscope, that lets us hear the patient, right, very loud and clear, the heartbeat and some other noises from internal organs. So that can be designed making use of these equations. Okay, one more example. So this, I have a lot of childhood memory with this example. Actually, when we were kid, I'm from a small village, so we used to go to the pond to take bath. But before taking bath, we would sit on the shore and dip our leg in the water, and then another friend will see and say, "Hey, your leg looks bent." Or you would take a stick and dip it in the water and ask a friend, "Hey, what do you think? Is this stick straight or bent?" I've tried to mimic that here. I have a pencil, I dip it in the water, and when I dip it, as you can see, the pencil looks bent, although the pencil itself is not bent. So this is called refraction, and there is a law for that, Snell's law. So this is after a Dutch scientist, Wilbur Snell. Sorry if I mispronounce that. But using this law, we can actually explain how the rainbow forms. After the rain, if the sun comes out, we see a rainbow in the sky. So we can explain that using this law. We can also make use of this law to design and deploy fiber optic. So fiber optic is basically it can transmit lots of data at very high speed, very close to speed of light, and far far away. In fact, over 95% of the international data goes through fiber optics. For example, if your friend uploads an image in US, you see that immediately in India, right? So most likely that is coming through fiber optics cable that is getting transmitted through that. All right. If you're curious about how it works, actually I have made some animations explaining those. It is already uploaded in our YouTube channel. This example shows how fiber optic works. This example shows how rainbow forms, or you have seen in diamond rings, when light falls on it, you can see some sparkles, how that sparkle comes. So I had done these two animations using Snell's law, and then I have done another animation where it shows how the Earth is rotating around the sun and how the moon is rotating around Earth and satellites. And I have another animation that very in a very simple way depicts the Mars orbiter motion, how we are able to send satellites to rotate around Mars. So I have used these two animations using Newton's law, and I have done another animation that explains how the how stethoscope works. So if you're curious about it, then feel free to visit the YouTube link, and then you will see this under explainer videos in our homepage. You can there is a section called explainer video. You can see that. All right. Now, okay, that's great. So the whole cycle is actually observe, formulate, and explain. But what do we need to focus on NEET and JEE? At the end of the day, that's what matters for us. How to get a good score in NEET and JEE, right? So for that, we don't have to worry about the formulating. Uh, we need so there are scientists have already formulated many laws. With that we can explain many things actually. So we don't need to, for NEET and JEE, we don't need to worry about formulating laws. But some of you may become a scientist in the future and discover new laws. Actually, that would be amazing. And then we are going to study about that. For NEET, we and JEE, we don't need to worry about this. What we need to worry about is observe and then explain. If you start observing the nature and try to relate physics to it, actually you will fall in love with physics, and that will really help you, make the journey to the IIT or REC or NEET or JEE, right? Very enjoyable. You'll feel like you're having fun while you're solving problems, and then using the existing laws, our main job will be to, there will be problems, so we want to solve those problems using those existing laws. So that is going to be the key for NEET and JEE. All right. Okay, so when we study events, right, we will talk about very complex objects like cars and satellites. So, but let the complexity not overwhelm you, right? Because we can always, depending on the problem, we can always make simplified models of this. For example, if I'm talking about a car moving at a certain speed, I can always model the car at a simple point. That's it. right? But when I talk about the ground friction on the car, on the wheels, um, I can just model it as a box on wheels. That's it. I don't need to consider about the engine and other things. I don't need to go into the complexity of the car. When I talk about the air resistance or aerodynamics, I need to consider the shape. I cannot consider it as a simple rectangle. I need to consider the shape, right? So depending on the problem, we can make different simplified models of the object that we are talking about. And that is so that is going to so basically I just want to say that we will talk about complex objects, but don't let that overwhelm you, because we will always make simplified models of that. All right. So what is physics? So physics is about studying the nature. It's about appreciating the beauty and functioning of the nature. It's about appreciating how simple observations can lead to very consequential results. And we already saw 3 examples of those. So physics can be really, really fun and fulfilling. Now, for this video, this is where we will end this video. Uh, Thank you for joining. Hope to see you in the next video. Thank you.